Today we're going to take a look at a really cool relationship between a series of perpendicular and parallel lines. And what we're trying to determine is how do A and F relate. So we have a starting point of A, and then we're told perpendicular, parallel, a bunch of different line segments, and then we get down to the end where we have some information about F. So we're trying to figure out how does A connect all the way back to F. First, we need to make sure we can identify these symbols correctly. That symbol means perpendicular. And this symbol means parallel. So let's just start going through the sequence of relationships. So first we have A is perpendicular to B. So I'm going to draw a line. I'm going to label this A. And then I'm going to draw a perpendicular line and call that B. Perpendicular means that the two lines meet at a right angle. So perpendicular indicates a right angle, like two streets cross. They intersect right at a 90-degree angle, right angle. So therefore, two streets are perpendicular if they cross at an intersection like that, where they cross through at a 90-degree angle. That's perpendicular. So we have A is perpendicular to B. What's next? Next, we're told B is parallel to C. So I have B. Now I have a line that's parallel to it. I'm going to call that C. Parallel means the same slope. They are going the same direction, same slope. Train tracks parallel, never cross. So we have B is parallel to C. Then we also have D is parallel to C, or C is parallel to D, excuse me. So then I'm going to draw another line segment going the same direction. So as we're building here, we can make some conclusions just based off of this. So if A is A is perpendicular to B, then A is also perpendicular to C, which is then also perpendicular to D, because B, C, and D were all parallel. They're all going the same direction. So if A is perpendicular to one of them, it's perpendicular to all of them. So we did that, we did that, we did that. Where are we at? We're at D is perpendicular to E. D is perpendicular to E. So E is going to come in at a right angle. Now, finally, E is perpendicular to F. So E is perpendicular to F. That means F is going to be coming out this way. Now we want to know, well, what is the relationship between A and F? What can we conclude about A and F? So if we know A and E, if we go back here, A and E, so if A just kind of goes through here, and A and E were parallel, and F was perpendicular to E, so since F was perpendicular to E, that means F is also perpendicular to A. So A is perpendicular to F. Now you can see that they cross right through at that right angle right there. A is crossing through F at a right angle. And these lines just extend forever. So if you're like, well, what if it didn't extend? What if it came from over here? Doesn't matter. They just extend forever. So F is going to go here. Hey, we're just trying to develop what the relationship is. So we could say A is perpendicular to F based off of the sequence of relationships. These are really fun questions. I always like to make sure I put these on like quizzes and exams for my geometry classes because I just think they're a lot of fun to show your knowledge of parallel and perpendicular, and it's almost just like a sequence of relationships and you're trying to get all the way down to the end. So I really enjoy these problems and I hope you did too.